Welcome to Tomorrow. I am Space Mike, and I'll be your Capcom today. We also have the rest of our crew. We have Jared and Sarah, and we also have a Benjamin. Today, Jared, first, what's going on?
Well, we have an explosive Enigma on the surface of Mars.
Wow. Okay. And Sarah?
And I've got hope for life on other worlds.
Ooh. That's awesome. And then on the observation deck, Benjamin has an interview.
Absolutely. I'm going to be talking with John and Tom of the Gateway Foundation on how they helped a plan to colonize the solar system.
Awesome. And then we will all come back together at the end and talk about your questions and comments from last week's show. This is Tomorrow, Orbit 11.27.
Good morning. How's everything up in the sky?
Now, before we jump right in, we want to give a huge thank you to all of the Escape Velocity citizens who have been contributing to this show. And without your guys' support, we would not be able to do this. But these folks are the ones who contribute $10 per episode on Patreon. They get free worldwide shipping from the Tomorrow swag store and voting rights on upcoming roundtable discussions and so much more. If you would like to become a citizen of Tomorrow, head on over to patreon.com/TMRO. Now, normally I would be talking about upcoming launches, or rather launches that happened this week, but there wasn't any. So
what the
we're just going to
heck?
have to look forward to next week. I know. This is my worst nightmare. This is my worst nightmare. Or at least it's become that, as I dream about that, of you guys just being just like, where are the launches? There wasn't any.
Is this the first week this year that there haven't been any launches?
I think so, honestly. I think this is the first week so far this year there hasn't been any launches. So
come on, China, Russia, somebody.
Right? Surprise Chinese launch. And I thought there was going to be a surprise Chinese launch on Friday, but that's been moved to Monday instead. Anyway, though, there's still lots of really cool stuff that's been happening. So let's get into it. What is this enigma that has been solved on Mars?
Yeah, so there's something really bizarre with this very cool sounding region on Mars called the Medusae Fossae Formation. Now, it's basically this soft rock deposit on the surface, and geologists have kind of been a little uncertain how it got there. It's roughly about a fifth the size of the continental United States, or what we would call the lower 48 here. And it's about 100 times larger than any similar formation that we see here on Earth. So that's sort of why it's been a bit of a head scratcher. Why is it so big? And it's made of sedimentary rock, and radar measurements, they're inconclusive as to whether it's low density porous rocks or a mixture of ice and rock. Now, there they are calling a group of planetary scientists from Johns Hopkins University. They combined radar data from probes in orbit and gravity field data as well from Mars spacecraft, and they found that the data pointed directly to porous rocks and not large-scale ice and rocks mixtures. Now, explosive eruptions would have created this feature, which would have spread ash and rock out to the surface, eventually allowing for cementing into that rock. Now, the deposit's high content of sulfur and chlorine also implies that these were explosive volcanic eruptions. Now, the size and length of these eruptions to make something as big as Medusae Fossae, it would have released enough gases to generate an atmosphere with enough atmospheric pressure that it would have allowed water to remain a liquid on the surface of Mars. However, the gases released, such as hydrogen sulfide and sulfur dioxide, that would have absolutely affected Mars's habitability. So sort of a mixed bag there. Like, you know, we figured this out. We also figured out that it could actually generate a thick enough atmosphere for Mars, but also it's gases that life is basically like peace out towards. So.
Do they have any sort of idea as to when this outgassing might have occurred?
Yeah,
was this billions of years ago? Or?
Yeah, they're thinking it was roughly about 4 billion years ago on the surface of Mars. So it's very shortly after the formation of the solar system. So, which is super cool. So.
Huh. Wow, very interesting. Well, there is one of our favorite spacecraft might be having some trouble. Sarah, can you enlighten us what's going on?
All right, so Kepler is in safe mode. So on July 2nd, it was put into a no fuel use safe mode due to a low fuel pressure reading. Okay, so NASA knew the craft was coming up on this this point. And they released in March a statement that said it's probably going to run out of fuel in the next several months. Looks like we're coming up on that. Okay, so the Kepler mission was launched in 2009 with 12 kilograms of fuel, or approximately 3 pounds for we colonials. And that fuel was expected to last about 10 years. Kepler mission is in its 9th year, so pretty close on that estimate, but we're not done yet. Kepler will remain in safe mode until August 2nd. And the reason for that date is that is Kepler's next window in the deep space network. Okay, so Kepler doesn't need much in the way of station-keeping fuel since it's in an Earth-trailing orbit, and it has reaction wheels for star tracking, but Kepler's big fuel consumption is swinging its high-gain antenna around to communicate back with Earth. Okay, so since the end of its primary mission in 2013, Kepler has been on an extended mission called K2, and that's been broken down into several smaller observing components called campaigns. Okay, it was at the end of campaign 18 when the low pressure sensor happened. Warning went off. And the team put Kepler into no fuel use safe mode to make sure that the telescope has enough fuel to turn back around and send the data home on August 2nd. After that is anyone's guess. The team will crunch the numbers and query the craft, decide if this is an actual end of the craft's life or if they can get a campaign 19 out of it. If not, they'll power down the craft and, well, it'll just drift in space for a while, falling farther and farther behind us, about 20 days per year. Its Earth. Its year is about 20 days longer than Earth. So it'll fall about 20 days farther and farther behind us until we eventually catch up with it again in 40 years. Right?
Just a hop, skip, and a jump.
Coming up on you.
Something that I'm curious about, and it makes me wonder if this is due to actually low fuel, or the no pressure warning is what kind of makes me wonder if there's like some other problem going on. But yeah, you're right. We're just going to have to wait and see what happens. And hopefully we'll get one more round out of it until we get the next follow-on spacecraft.
Exactly. Yeah, they don't want to turn the craft off until they absolutely have to.
Well, the nice thing is that TESS is getting ready to, the Transiting Exoplanet Survey Satellite, is getting ready to start its science observations in just about a week. So it's literally like a handing of the baton. It's like Kepler's like, I'm done here, take this. So
well played, NASA.
Well done.
So yeah, even if it's the last the campaign for Kepler, at least we got good data and it's all good because our next one's coming online real soon. So
with a larger view of the sky.
So, Jared, you have some other stuff that you want to talk about regarding Uranus, or as I like to call it, Uranus.
Yes, that is correct. Absolutely, 100%.
There seems to be some information that has flown over people's heads here. What's going on?
Yeah, now the universe seems to be writing its own jokes these days. So let's venture out to the outer solar system, and we're going to talk about one of our favorite ice giants, but we're going to be very respectful because we are not going to make it the butt of any jokes. We're going to talk about Uranus out there. So research was just published from Durham University's Institute for Computational Cosmology that has helped us confirm that Uranus most likely was impacted by an object early in the formation of our solar system about 4.6 billion years ago. Now, this ended up being both the cause of the tipping onto its side, making Uranus's atmosphere colder than we'd expect. Now, the Durham University Institute for Computational Cosmology, they ran more than 50 impact scenarios through a high-powered supercomputer to find a result that gives us exactly what Uranus currently looks like, and one outcome gave just that. The impactor that hits Uranus, it has to have a minimum mass of twice that of the Earth. So that's a big old thing out there getting ready to hit Uranus. And in addition to that, it has to make a grazing impact, sort of like what we're seeing in the actual data from the supercomputer simulation here. It just barely skims across, and it kind of ends up destroying the impactor on the second and third time around. Now, this was enough to knock Uranus off kilter. And this explains why Uranus orbits around the sun with its axis tilted at 97 degrees. Now, for comparison, the Earth's axis is tilted 23.5 degrees. So just to give you an idea, so Uranus is over on its side. So that means that your seasons are literally like endless daylight or endless darkness in some cases. Now, that grazing impact, it allows Uranus to retain most of its atmosphere, but it also allows for debris from the impactor to form a thin shell deep within that remaining atmosphere. And that thin shell prevents the heat from inside of Uranus moving upwards. And that actually ends up explaining Uranus's cold atmospheric temperature of negative 216 degrees Celsius. Now, they're actually going to do additional research with this study that was done to see if they could get more details about Uranus, such as how its ring system formed, how its moons formed, and also why the magnetic field formed off-center. Because not only is Uranus tilted, the magnetic field of Uranus also seems to be disconnected and kind of waving around as well. So it's a weird place.
Well, even just looking at these simulations, though, I mean, it makes me wonder if the follow-up study to this will be that maybe the impactor, although it might have been broken apart, maybe coalesced eventually into Uranus's moons. I mean, especially Triton is really, really weird. And the fact that they all orbit, that's the thing, though. Like, were they already orbiting and just kind of tilted with Uranus, or are they orbiting polar because they are the leftovers of whatever that impactor was?
Yeah, so I would be very surprised if it didn't turn out that the impactor caused the tilt and the debris left over went into that axial tilt as well to form the rings and the moons. It would take an immense amount of complication in order to take a ring and moon system and move it towards near vertical or downwards, whichever you prefer. That would just blow my mind if that was even possible.
Technically, they're still orbiting equatorially, so to speak. They're not exactly, right on zero or that, but from our perspective, it looks like they're, the ring system and the moons are orbiting like a polar orbit, but they're really not, because the poles are tilted to the sides. So,
they're not orbiting over the traditional poles of what we would call a polar orbit. They're literally rotating around Uranus's equator, which is 97 degrees off off level or out of the ecliptic of the or that plane that all the planets lie in our solar system. So, what a mess! It's an absolute mess.
Yeah. We need a probe there someday.
Yes, I agree.
A second ship.
Speaking of probes and things that we're searching for, there's some hope out there that there might actually be some life that we didn't know about. What's going on with that, Sarah?
Okay, so more and more research is supporting the possibility of life on other worlds. We know that Jupiter's moon Europa and Saturn's moon Enceladus have liquid water below icy crusts, and we know that Mars has liquid water in its soil. We also know that those worlds are not cold, are cold. They're freezing cold, but they are not frozen. And while freezing sounds pretty good right about now to me, it's that last bit that's really important. They are not frozen solid. And we think part of the reason that the water of these worlds isn't frozen solid is that it has salts dissolved in it, and those salts are acting as an antifreeze, which could be bad for bacteria, but a far-flung team of researchers from the Technical University of Berlin, Tufts University, Imperial College London, and Washington State University released findings in NASA's Astrobiology magazine on Wednesday that are pretty encouraging. Now, the team's findings indicate that bacteria can survive in the environments we expect to find in these subsurface oceans. The researchers chose a bacterium that lives in Earth's Arctic permafrost called Planococcus halocryophilus.
Sounds good enough.
All right.
Sounds close enough to me. Yeah.
And they exposed they exposed these bacteria to solutions of sodium, magnesium, and calcium chloride. They found that the salt solutions lowered survival rates at temperatures near 0 degrees Celsius, but as you lowered the temperatures, survival rates grew. And the temperatures were different for each of the salts because they lowered the freezing point of the water. So as you got closer and closer to the freezing point of the water, the bacteria survived better. And the reason for that is the cold actually inhibits the caustic effects of the salts. And they also exposed the bacteria to freeze-thaw cycles, kind of like what you would experience on Mars, going from day to night, and winter to summer. And they found that salt water helped with survival rates. Now, the researchers also exposed bacteria to perchlorate solutions similar to those in Mars and some more extreme solutions just to see what would happen. And here the findings were less encouraging, but not altogether defeating. According to lead author Jacob Hines, the presence of perchlorates wouldn't preclude life on Mars or anywhere else. But the team was pretty clear that you need to make a distinction between survival rates and growth rates. Bacteria can survive in these climates, in these environments, but they're not really growing in these antifreeze solutions.
Yeah, I don't know.
Go figure.
I don't know a lot of things that would survive
Right?
antifreeze. So, humans tend not to.
Yeah.
So
Yeah, we avoid that.
yeah.
It makes me think of a couple of years ago when we had certain parts of the ice sheets falling off, and there was all that primordial ooze that was coming out that had somehow survived. It didn't grow, but it had survived in those sort of conditions. So yeah. I mean, if that can happen here under similar, chemical conditions, then why not elsewhere?
Yeah, and those bacteria would have evolved in their natural environment. If something was deposited there, they would have a chance to evolve over a couple, billion years.
Yeah, I wonder if like tardigrades can handle it, because they're considered one of the toughest things here on Earth, and we find them buried in ice sheets that are tens of thousands of years old, and we pull them out, they come right back, right from where they were at. So
what's the phrase?
Yeah,
antifreeze water. Water bear don't care.
Yeah, yeah. Yeah.
It sounds like
Water bear don't care.
Water bear don't care. Water bear don't care. So,
Water bear to Enceladus before the end of the decade. Come on, let's make it
Yes.
happen. Come on.
Let's just fling them into space and no.
So that's how we're going to colonize the stars.
Eventually.
We're going to send out tardigrades.
They are our welcome wagon.
Oh, man. Oh, man. Well, let's go ahead and take a quick calendar break. We do have some launches, hopefully, for next week. So we're going to take a quick break, and then when we come back, we're going to have an awesome interview for you guys. So stay tuned. Tomorrow we'll be right back.
Look into her face, determination in her eyes. She won't give up or quit or fall for little fashion lies. Filled with awesome expectation, this girl's a fascination. And nothing in her way will keep her from her destination. Cause she's fire walking, she's fire walking. When it's hot, she keeps on moving. Through the heat, keeps on improving. Yeah, she's fire walking, she's fire walking to be free.
Welcome back. Now, before we get into our interview, we wanted to give another huge thank you to our escape velocity citizens. But not just that, we also wanted to acknowledge our orbital citizens. These folks contribute $5 per episode or $15 a month on Patreon. And if you would like to become a citizen of tomorrow, head on over to patreon.com/TMRO. And now Benjamin has a really awesome interview with John Glencoe and Tom Spilker of the Gateway Foundation.
Yeah, thank you so much, Space Mike. As you said, we've got John and Tom from Gateway Foundation. I wanted to start off with, before we get into like what you are and what you're trying to do, why? Why space? Why? This stuff is extremely hard. What drives you?
Oh, for me, that takes me back to my childhood when I used to watch Star Trek. And I used to love to watch Captain Kirk and the crew going places and having these adventures and so forth. That's what space is to me. I don't want it to be a couple of people doing science in a module someplace. I want there to be a crew. I want there to be people there enjoying things and doing things. It's bigger than something small. That's what it is for me.
People living and working in space.
Yes, a whole culture. A Starship culture.
A Starship culture. You're building the Starship culture.
I'm borrowing that term, though. It was Dave Barnhart who wrote a paper for DARPA and talked about the Starship culture when we start to build things in space. And so I'm kind of borrowing that term.
That's a great term. I hadn't heard it before. That's a great term.
I'll give you that paper to read later on.
Oh, yeah, absolutely.
Yeah.
Why?
I tend to think more about the humanity's reasons for going to space. I'd like to see humanity stick around for a while, and Earth is limited resources. Especially resources that can be wiped out by an asteroid or something like that. And I just feel that for humanity's future, we need to establish ourselves as a spacefaring species.
We do.
And so this is the way that we get there.
More so of a spacefaring. I mean, because we're in space right now. There are 6 humans in space in low Earth orbit right
Is
now.
that
But
spacefaring,
permanently spacefaring.
Yes.
There's always somebody up there doing more than just twiddling the thumbs and going around in circles. You know, people are working up there now, but it's at a very low level. We need to establish something that we would call a culture in space. Get enough people up there, and notably not dependent on the resources of Earth.
Not just a few people.
Yes. To establish a permanent human presence that's dependent on space resources, not Earth resources.
So you start with spaceship culture or Starship culture, and then you move to just general space culture, like as you extend beyond that.
Yeah, and build ships to go further out to do more too.
All right. Yeah. So let's talk about exactly that. So you're with the Gateway Foundation. You're president of the Gateway Foundation.
I am.
So what is the Gateway Foundation? What are you trying to do? And I realize that is a complicated question to answer because it's a lot of different things. So just at a high level.
It is. It's the end goal is to build a rotating spaceport. You start with that in mind, but you ask yourself, you know, we're back here at ISS, and we need to get to here, rotating spaceports. Then you have to start thinking about all the things in between to get there. You have to have a space construction industry to build a spaceport. So how do you start a space construction industry? Well, you have to have at least one space construction company. So we started Orbital Assembly. Now you have to have the equipment for that company. So we started thinking about, you know, how do you build things in space? And that's when you get to bots, pods, and drones, and things like that. You contract out for these things. You can't make them yourselves. Construction companies today don't make their own gear. We know the companies around the world that make things like this. They can make the bots, pods, and drones that we need. Boston, what's that company that makes the robots?
Boston Dynamics?
Boston Dynamics. Their robots are very versatile. That's the kind of thing that we're looking for. And they're looking for funding all of a sudden. What a perfect match. We need bots that they can make. They need us because they need a marketplace.
But you're more than just on-orbit construction. Like you've got a pretty broad vision. You talk about how you're going to get these other companies to build products, but you need to be able to pay for it somehow. So how are you going to fund that? And I realize I'm going all over the board already early in.
We're with you.
But yeah, I mean,
you're right.
I mean, that's the big thing with space.
And that is exactly where I got into this. It wasn't the fact that I just wanted to build a spaceport. I asked myself, how do you pay for a spaceport? We're talking hundreds of billions of dollars per year, or certainly somewhere in between there, depending on the launch costs. But how do you get this kind of money? How do you get spaceport money rolling? That was the question. And I came up with the idea of a lottery. And I thought I was so smart. I thought I was the first one to do it. It turns out I wasn't. Buzz Aldrin actually had thought of it years before with his Share Space program. He wanted to use a lottery to fund people's trips into space, not to build a spaceport. But when I was thinking about a spaceport, I was thinking about it builds an entire economy around itself. It creates several industries all at once. If you had a lottery running worldwide, then you could do it.
All right, so you're not the numbers guy. You work on.
I'm sorry.
You are the numbers guy. You're not the
numbers guy.
You're not those numbers.
Numbers with units like kilometers per second or kilograms of propellant, not dollars and full-time equivalent employees.
So you right. So no dollars, just units. What is your role inside of Gateway Foundation?
I'm the chief architect.
What does that mean?
I do the math. When John says, I want to send a 50,000 kilogram spacecraft with 40,000 kilograms of payload from low Earth orbit to the moon, I'm the one that calculates what orbit would you need to do that, how much propellant does it take to go from that low Earth orbit along that orbit to the moon and insert, say, into a circular orbit at the moon. I keep the physics
He keeps us honest.
So how hard are the physics here? Specifically, like you're asking a lot. I mean, that's a good chunk of payload going to the moon, and Earth's gravity is cruel. So how hard is this to do?
Well, we did it almost 50 years ago.
Yeah.
But not sustainably.
Not sustainably. But you know, people have had ideas. Surprisingly enough, over the past 50 years, people have had ideas that have actually improved the state of space exploration, improved rocket engines so you get higher thrust to weight ratios, improved the specific impulse of the propellants and the specific impulse you can get from engines. And so things have been improving. And because during the Apollo era, we were on the hairy edge of being able to do it, it took a huge effort to do it. Little improvements make a big improvement in what you can do. And so we're building on these little improvements that have happened over the past 50 years, and these will enable us to do things that are much more difficult than Apollo kind of hardware would be able to do.
And you know, one of the things I talk about in some of the videos that I've made about the business model for the Gateway is how we have so many launch providers springing out of nowhere. You probably have a new one every week.
Oh, we do. We do. I think. Does anyone have the running tally? It's well over a dozen.
Oh, more than that.
Yeah,
it's got to be 2 dozen.
Yeah, it is. It's a lot.
I can name a dozen.
It's yeah, it's a lot. But a lot of them are small sat launchers.
And that's what I think is going to push SpaceX into the bigger realm of things.
Well,
and
BFR.
Blue Origin. I think that the small sat area is, you know, because they want to launch small sats too. They want to have carriers that are dropping off CubeSats and small sats and everything as they're carrying a bigger payload up. I think they're going to have a hard time competing with the new Electron, the rocket from Rocket Labs.
Yeah.
And all the others who are doing the same thing. They're going to be pushed out of that market, pushed right towards what we're doing. They're going to be pushed into the heavy lift realm of their lift capability. And that's a natural progression. And that's exactly what we want. We want competition coming our direction for the heavy stuff that's going up. Now, we haven't got competition for BFR. Right now, that's...
New Armstrong, Blue Origin.
That's coming.
Well, so is BFR, I mean, to be fair, right?
But they're so much further down the road. Of course, that's hard to tell because Blue Origin is very secretive. But the thing is, you know, BFR is going to come up first. So that's what we talk about a lot. Now, if Armstrong is there, that's great. That's even better. But the thing is that we're going to give them reason for what they're doing. Right now, when they look at a marketplace for lifting, you know, what is it, 150 metric tons? You know, who's going to need that? We are. We're going to need it every week. And then later, 3 times a week. You know, we're the purpose for them, and we're the money for them too. And that's where you start to come into the business model. How do you get this kind of money?
Yep. All right. Go. You mentioned a lottery, but I mean, you're talking about a lot of money here.
We're talking about, yeah, a lot of money every week, basically, every year. The lottery is the only vehicle outside of government that you can get this kind of money rolling in. But the beauty of the lottery is it ties it to the people, not to the government. All money has strings. NASA strings tie right to the government, not our money. It ties to people like you. You want to see this built. You want to go into space sometime in your lifetime, along with 1 million other people. They'll play this lottery. They'll support this idea. And when we have a customer that we have to satisfy every week, we're going to be taking them up. That's a really good relationship right there. That's how the lottery is going to work.
Is there a bit of a chicken egg scenario here? Because if you're a well-established player and you're already going to space, and you go, by the way, there's a lottery if you want to join us here. That's an easy sale. That's super easy, right?
Yes.
I'd be like, oh yeah, absolutely. They're already doing it. I want in on that. But before you've ever done it, it's a bit of a riskier proposition. Is there a way around that, or do you have you considered like how are you going to get that initial funding going?
Yes, exactly. That's one of the reasons that we started Orbital Assembly. Orbital Assembly is going to be a construction company. It's going to build all kinds of things. It's not dependent on the lottery at all. The first projects, which we show on the website, are probably smaller things like space telescopes, fuel depots. And the newest project that we're working on right now that we're really excited about is Von Braun. Von Braun is going to be a rotating space station, not a spaceport, but it's the perfect thing between a spaceport and ISS. It's basically taking ISS and a bunch of its modules and starting to spin it. But a bunch of modules, 24 modules. And these are the same ISS-sized modules which were designed to fit inside the shuttle. They'll be designed to fit inside larger rockets like BFR. So we're talking 30 feet by 50 feet. These are big modules.
And I don't think
of them.
we were talking before the show. You hadn't talked about Von Braun too much beforehand, so
it's new.
Yeah. So, and I think Dutta, you might have some images of Von Braun. Good luck finding them. We'll give you a moment.
This is an image of Von Braun during its construction phase. Actually, that's with the first 2 modules in place. What you're seeing here is the inner ring set, which is the docking area, and then you're seeing an outer ring set, which is replicating the LGA and the gateway, in case any of your viewers have seen that. We're going to learn so much in building von Braun, because this is the whole thing of what the gateway spaceport is: hub, spokes, and outer habitation area. All of this replicated in an early stage in a smaller set to build is exactly what we need.
Why? Like, why do we need to do this testing? Why can't we use the testing we have on station right now? What does this get?
This is artificial gravity. They don't do that there. They're in 0G, and they're doing a lot of smaller experiments. They're not looking at the bigger picture of humankind moving into space or going from place to place. They're looking at, under gravity, I mean. They're looking at all the 0G experiments you could do, without gravity. And that is such a mistake. Well, I shouldn't say a mistake. What we've learned from what they've done has taught us this is the wrong direction to go. Humans' bodies are falling apart in space. Mm-hmm. Their vision tends to weaken. Their brain moves inside their brain case. Tom could tell you even more of the physical aspects of what happens to your spine and so forth. It elongates and so forth. What we've learned about living in 0G is we can't really live in 0G, not for any long periods of time. You can do okay for a short time if you don't mind the puking and so forth because your stomach's getting used to that. But it's not the way to go. We need some gravity.
So we start spinning the station. What do we think is going to happen when we start spinning the station? Are there going to be unforeseen consequences? I mean, if I get in a centrifuge and I start spinning, I start feeling ill.
Heavy G.
Yeah, heavy G, that's true. But I mean, we don't know what's going to happen in space. Do we have any ideas?
Well, there has been research in that direction. Not a whole lot of research, and certainly not research in a 0G environment spinning up to an artificial gravity environment. There will be a lot of things that we don't think about ahead of time, and that's why we need to look at what are operations in a spinning space station like. We're pretty well familiar now with how do operations go in a 0G space station. Skylab, Mir, ISS have all spent a lot of time looking at how do you do operations, how do you transfer 500 gallons of water from here to there in a 0G spacecraft, a 0G space station. We're not so familiar with exactly how does that go when you have a spinning space station. You can do the physics and so on, but there's nothing like being out there and actually trying it to tell you, oh, well, these valves on this water distribution system get kind of funky when you go beyond lunar G, and so we need to do something different there. There will be all kinds of little things that we find out with how do you operate when you're a rotating space station and eventually a spaceport, that there's really no other way to find those things out.
And that's why we need to get out there and do this.
Sure.
We need to start building rotating space stations so we can learn the basics so we can build rotating spaceports. The real money of space is not going to come from governments. There's going to be some, sure, but the real money is going to come from you, yourself. I want you to fork it all over right now.
Right now. Grab your checkbook, let's go.
Really, I mean, the citizens of the world are going to pay for this through tourism. Just the way that you look at airports around the world. I mean, what supports airlines? I used to work for one of the biggest airlines in the world, United Airlines. They had 500 airliners. That was just one big one. And there's 10 that size, and there's 100 more that are even smaller. We're talking, $1 trillion in equipment, and most of this is not government subsidized. This is just the free marketplace. Mm-hmm. The real money always comes from the people. Apple, the most valuable company in the world, where do they get the money from? The government? No. They get it from people like you and I. That's where the money for space is going to come from too. By bringing people into space, bringing them into the marketplace, that's where you're going to have the real money and the real expansion, the real growth.
Is it going to take time for us to shed the idea of government paying for this? Because since the Apollo era, for better or for worse, we've always just assumed this is a space is for government, right?
It's already happening. When you look at the spaceship company making spacecraft, so the Virgin Galactic, the first space line, can take people up, and the same thing with Blue Origin and their craft too. It's already happening. It's already started. The ball is going down that road. It's just going to get bigger. Both those companies are lacking a destination. They go up and they come down. It's a ride, and it's a fantastic ride. I would love to take it. But the thing is, imagine now when you can take tourists to some place where they can settle in. And not like ISS where you're in this giant laboratory with a million wires hanging around, looking like the back end of a Radio Shack, facility. No, this is the hotel experience that everybody wants. You check in, you've got a real room with a real bathroom, and you're going to go to a real restaurant later on. Now you get out of bags or cans. That's what they want. You bring that to them, all the money you need is going to come with that.
It's going to take some time to get there.
Yeah, you're right.
So going backwards a little bit, I have a question from the chat room, and I don't actually understand it entirely, so I'm going to ask it and then sound like an idiot, but hopefully you can help explain it. This is from Lur, and it says, given the rotation of the station, how will you solve the problem of precession?
Good question.
So I don't understand what the problem of precession is.
If you have a rotating, anything, a gyroscope, a space station, whatever, and you apply a torque to it, it will cause a precession. Say if you've got a plane of rotation like this, and you apply a force here, you're trying to rotate it this way, but something rotating doesn't behave that way, it'll start rotating this way. If you need to precess the station, and that would imply that you're in a particular attitude in a particular kind of orbit, you would at times need to precess the station. You need to know, where do we apply the force to make the plane of rotation change the way we want it? And that physics is very easily solved. It's been done for a long time. It essentially boils down to, where do you want to put either rocket engines or momentum wheels or reaction wheels to apply that torque to do it. We haven't gotten to the point where we've decided we're going to go one way or the other with reaction wheels or rocket engines or so on, but there are options available there. There are certain orbits, for instance, if we go into a sun-synchronous orbit around Earth, if this is Earth, that sun-synchronous orbit, you're the sun, is something like this. It's 7 degrees away from a perfectly polar orbit if you're in low Earth orbit. But essentially it sees the sun all the time. And if you put the plane of rotation of that space station face on to the sun, then you never need to precess. You'll be going around in that orbit always the same side facing the sun. So if you have solar cells on one side of the spaceport, they're always illuminated. You never have to change the attitude of the station to keep that up. And so there are certain combinations of orbit and initial attitude that you don't need to precess.
And the sun-synchronous orbit has a lot of advantages. That's one of the reasons that Tom shows that orbit for us. It's thermodynamically stable. You're not doing what ISS is doing, which is going in and out of bright sunlight, a lot of heat, back into extreme cold, which causes this thermodynamic stress, which is aging ISS very fast. Keeping it one temperature all the time is going to be a very good thing for a space station, we think. But like you say, we're doing this for the first time, so this is our early ideas of the way it should go.
For some objectives, and one of the objectives is get people up there and let them see things, but there will be other things that we use the port for. There will be engineering purposes, people building equipment up there. There will be scientific purposes, people experimenting with various levels of G and how people adapt to that. The polar orbit seems to work for all of those. But there may be some later on that, the polar orbit doesn't work too well. And we may build a second gateway that's not in a polar orbit, not in a sun-synchronous orbit. It may be closer to equatorial, and then we'll have other problems that we need to solve, such as occasionally we'll need to precess the entire station. There will be this thermal cycling that John was talking about, and as he said, that ages equipment quite a bit faster than a nice, steady thermal environment. So indeed, there may be reasons to go into solving those problems that you wouldn't have with the sun-synchronous orbit.
From a thermal standpoint, you're kind of looking at it from either stay really hot or really cold, just don't go between them constantly, right?
Right.
Because then you solve for really hot, and now you're just always really hot, or vice versa.
Well, the cycling back and forth causes thermal stresses in materials, and it can cause cracking and various kind of things that really aren't good for large structures.
Von Braun's designs, his earlier designs of spaceports, used a working fluid in sunlight to create energy. He was going to have it come around to the sunlight side, heat up, and then it goes around the backside and it cools down. So for this expansion and contraction of those fluids was going to turn turbines.
That's clever.
Yeah, there's lots of ways to do this. We just haven't been thinking about how to do this, and we need to go down this road. How do you build it? How do you operate it? And one of the things we're going to be using a lot is water. Water for nutation, for balance, water for dampening vibrations and so forth. There's a lot of things you need to think about when you start doing this.
Where do you get the water from? Are you lifting it from Earth?
You're lifting from Earth.
That's heavy.
Initially.
Oh, okay.
Yeah.
So what's the long term then?
Well, it looks like there are lots of reasons to use materials from the moon, especially if you can use lunar materials not only to make the materials you need in low Earth orbit, but use lunar materials to make such things as aeroshells that will allow you to do a lunar to Earth transfer, and then instead of spending a lot of propellant, which is hard to come by when you're leaving from the moon, you use an aeroshell, an aerobrake, actually closer to aero capture. You do a single pass through Earth's atmosphere to break your orbit down from a very eccentric orbit to a near circular orbit, and save a lot of propellant that way. And you've delivered a bunch of refined lunar materials plus the remaining aeroshell materials to low Earth orbit from the moon. So the use of extraterrestrial materials looks like it's a distinct possibility.
And space construction, building spaceports, building space stations. This is going to give rise to lunar mining operations, or in space situ utilization of those particular asteroids and so forth to turn them into metals. Who's going to buy structural metals right now from people who are mining in space? We will. That's going to be the marketplace. So, when you start building something like this, you get all these industries. Who's going to refine those structural metals when they come out of those asteroids now into usable metals, into materials, into wall panels and so forth? That's going to be another industry. Space construction spans all of this, not only the building of the spaceport, but the refining these materials coming from in situ resources.
Sarge Amazon asks, what would the power requirements for Von Braun and later stations be? So how are you powering these things?
It'll be solar. Yeah.
Because in space you got a ton of sun.
Exactly.
And if you're in a solar orbit, then you
getting it all the
always
time.
got a lot of sun.
Yeah.
Yeah. Assuming you're on the sun. Yeah. Yep.
It would be solar.
And if you coated one side of each of the modules on Von Braun with solar cells, you would be getting megawatts of power.
Yeah.
All the time.
Power is not going to be a problem. You've got a lot of that. You have other things you need to worry about, station keeping and so forth, orbital boost. Those are the bigger problems that we look at right now. Where do you put the engines? How do you push?
Well, aren't there next generation engines that require an obscene amount of power, which makes them unrealistic for space, that would help you for station keeping at that point? Because if you have obscene amounts of power, you can use these engines for station keeping that require obscene amounts of power.
You're talking about electric propulsion engines. Yes, there are small-sized electric propulsion engines. Now, some people wouldn't say that the next thruster that NASA has been working on, which is something on the order of 10 times as large as their N-Star engine, they would say, well, that's not large, or that's not small. Well, when you're talking about pushing around hundreds or thousands of tons, yeah, the next engine is small. And of course, they do take a lot of power. The more specific impulse you get out of the propellants, the faster you throw those ions out of that ion engine, the more power each ion takes. And so if you're wanting to be very efficient with the propellants, whether it's xenon or cesium or whatever, then you're going to want more power into those engines. We will have lots of power. People will need to build larger engines or very large clusters of smaller engines. If you can fire those engines almost constantly, you'll never need such things as pre-planned maneuvers. You can run those engines such that they're always making up for drag losses. And so there's no orbital evolution due to drag loss. If you're using pulsed engines, like if you use normal chemical rocket engines, then you'd be pulsing those engines. You'd wait until you lose a certain amount of altitude due to drag, and then you would fire those engines to take you back up to normal altitude, which is essentially what ISS does.
Maltham from the chat room asks, we've been talking about very large, very grand scale plans using BFR, possibly New Armstrong very large modules, even for some of your test stuff. Is it possible to build something automated on a smaller scale, say Falcon Heavy liftable, to start answering some of these questions?
We planned on using Falcon Heavy at the start before BFR came along, because we started back in 2012. And BFR wasn't really talked about. In fact, it wasn't even invented. They were talking about something else, MCT, I think, at the time. And so we based it all around the Falcon Heavy. And we had the numbers that would work out for Falcon Heavy and everything. BFR makes this all more possible because it's cheaper to launch more materials. So yes, we could do it with the Falcon Heavy. That's the way we'd planned it. It just makes it better with BFR or New Armstrong because it can lift more for less money. The money goes further.
But that's some of these testing things. If you're doing you're talking about the bots and pods and whatnot. Actually, go a little bit more. I don't think we covered bots and pods very well. So what are you trying to do there? I know we covered a little bit in the beginning.
These are construction tools, and they all play a different role. The bots themselves are kind of an assistant to an astronaut in a suit. Astronauts in suits is kind of a messy ordeal. It takes a long time to get into one. You're very limited in what you can do inside, and it's very dangerous out there. If we can train the bots to do the things we want them to, especially in repetitious situations, like in construction, where they're kind of doing the same thing all the time, a bot is perfect for that. Once he's trained, you just let him go do it. And if he runs into a problem, you go into a different mode of bot operation to where you're in virtual reality, where someone on the ground, wearing a headset and so forth, retrains the bot to handle that situation, then he goes back to work. The pods and the drones, these are specialized equipment. Pods are really the cranes of space construction. They're going to be moving heavy things around. Now you can use arms like NASA did, but arms have a hard time moving. They have to have a power port wherever they go. Not with a pod. A pod, you can move things kind of wherever you want to at the particular time. So all these different types of specialized equipment, they need to be developed. That's why we need projects just as much as we need the equipment. You can't develop these projects, this equipment, until you've got a project to start working on.
Sure.
So.
But you don't necessarily need a Heavy or a BFR to launch some of the pods and bots.
Right.
That can go up on.
It could go on a Falcon 9.
Yeah, exactly. And if you're teamed up with someone who's already looking to test some of this stuff, you could start sending that up now for testing and whatnot.
Right.
Yeah.
With the exception of one piece, which is the G-cell. The G-cell is a specialized piece of construction machinery designed to build very large structures very quickly. That wouldn't fit inside of a Falcon 9. It might not even fit inside of a Falcon Heavy. You'd probably need a BFR to lift that up in chunks. Now, if you wanted to build the G-cell in space, then you could launch it up in smaller rockets. But you wouldn't need one until you're building something big anyway.
I don't think we've talked about the G-cell yet. So it's the machine, it's the space station making machine?
Right.
Yeah,
yes.
so
It's kind of like Trusselator. Trusselator does things on a smaller scale. Trusselator makes trusses to build structures. G-cell could use entire trusses to build larger structures all at once. It's a marriage of several different types of older construction technology. One of them is what they use in shipbuilding, which is where you take a chunk of a ship and you build in a shipyard and you put all the chunks together, the pieces together at one time. Another type of construction is the assembly line, where you're actually building pieces of a structure in an assembly line very fast. And then, of course, there's permanent modular construction, which is really the core of what the G-cell is doing. You see the permanent modular construction used in building hotels in China, where they show them being built in 15 days, this whole hotel. It's that kind of thing. You make the same type of piece very quickly, and you assemble very large structures very fast.
So AD from YouTube is asking, how long will it take to bring these materials up and build a station?
To bring the materials up? Luckily, when you're building a space using structural components, the material fabrication isn't that long. It's a bunch of I-beams you can throw together, specially cut I-beams for each part of that particular part of the space station. It's the G-cell that we have to work on. We have to build one and test it and have it start making things like von Braun. The big rings of the von Braun could be used. It could be built using the G-cell. It's that kind of thing. It's not going to happen fast, sadly. But when it starts to happen, it's going to happen. It's going to be built rather quickly. It's going to be impressive.
So it's like foundation work for a house, right? It takes forever to see that initial work, but once you've got that down, the rest of the house just pops up right around it.
Good analogy. Yeah.
There's another analogy you can make to the space science program that NASA runs. How quickly do you make progress in space science? Well, it depends on how fast you pump money into it. How many missions can you fly per year? The more missions you can fly per year, the faster you go through all of the questions that planetary science has raised. And this would be similar. The higher the funding level, the faster it would be done.
Do you see launch providers reaching a cadence that would be acceptable to the levels that you need, right? Because traditionally, you launch a rocket, maybe, a classification of rocket maybe 6 to 10 times per year. But it sounds like you're going to need a lot more than that.
Yeah, when you build a spaceport, you would need a lot. We see the maximum pace of payloads being delivered to the construction site for BFRs as much as 3 times a week at the highest pace.
There's not been a rocket ever that has launched that at that cadence.
Right. You would have several, BFRs operating on something like this. But at the start, for smaller projects, you wouldn't have that kind of rate. It would be much, and especially at the start when you're just working on the equipment that's doing things, the bots, pods, and drones. When you have them up there driving around and building small structures, you're talking about 1 launch a month or something. It's gonna all build up at once. The capabilities of the rockets, delivering materials, and the pace of our building, it's all going to build up at the same time.
The launch service providers are going to love you guys.
Of course. Yeah.
Now, Elon Musk has actually talked about the cadence of launches, and he has said something about he would like to see in the not too distant future the Falcon 9 reuse be in a matter of days. You get one back and it launches again days later.
Yes. I talked to the head of sales in 2015 about this. I can't remember his name right now. Anyway, he was saying at the time, Elon Musk wants their rockets to be launched up and down 10 times before they do anything. It's just gas and go. That was in 2015. And they've been working on that ever since then, that rate. Mm-hmm. So I think they're going to do it. But they need us. They need a project that needs rockets going up that frequently.
Sure. So from the chat room again, Citizen 6339 asks, what's your timetable for establishing that lottery, and when do you plan on bending metal for test articles?
The lottery is going to take time. We're talking about now a legal process. It is illegal to start your own lottery, but it is legal to change the laws in any state which has the initiative process. That's 24 states in this union. Any one of those 24 states could be convinced that, yeah, let's let this construction company do their thing with the lottery, and we're going to get a lot of money from it. And California, of course, being prime, because we have the launch providers here and a lot of people who are doing other things in space, too, that would benefit from this. So any one of those states that changes their laws to allow the lottery to run. But it takes about 9 months for the initiative process just to start to end. And we're not even close yet. To get a law on to come up on an election, we're talking 500,000 or 600,000 signatures. Mm-hmm. It's not an easy process. Some countries might be more willing to start the lottery there. You might be able to go to the UAE and they might just say, yeah, this is a good idea, let's just do it. Whereas here you have to go through the legal process. So where it will start, when it will start, I haven't got answers for that. But I do know that it will start because it's just a good idea whose time has come.
Yeah, I mean, it sounds like this isn't a thing for U.S. citizens. This is a project for all of humanity.
Right.
So it doesn't necessarily need to start here in the U.S.
Right.
I don't know if they still are, but just throwing out Isle of Man was huge into space not that long ago.
Yeah, they could do it too.
Yep. And bending metal, and I know that you're trying to temper expectations on timeline, but let's just say you've got the lottery going. It's whatever time, and then from when the lottery starts, how long do you think it would take for you to start bending metal, getting ready to start send up test articles and things like that?
On von Braun or on Gateway?
No, I think the question is just in general on probably von Braun, because von Braun starts first, right? Just to kind of get the momentum going.
Good question. The reason I like this question for this one is because von Braun doesn't require the lottery to be running. We're going to be looking for sources of money outside of the lottery to build von Braun. We want countries to step up and say, yeah, I want a module. This is artificial gravity. We're not going to miss out on this. We could see America buying 3 or 4 modules because they're going to be a lot cheaper than the ISS modules. And they wouldn't want to be left out. They wouldn't want to see China buying a couple modules and doing pioneering work on artificial gravity and everybody missing out. And also, the price of these modules are going to be a lot cheaper. We have a joke running that James LeBron could buy his own module because he's worth about $400 million. Well, what if these modules were $400 million? He could have his own basketball court inside of his own module in low Earth orbit, jumping 6 feet in the air, making, do whatever he does. So there's a distinct possibility that haven't come up before just because the economic model is going to be more conducive to what our situation is right now. The investors coming in, I mean.
Switching gears a little bit towards engineering, Tawicket from the chat room asks, how would you build a multi-layer hull with a modular design? they've been showing the animations and whatnot, and that seems to show a single layer, which wouldn't be the best for long duration station.
Which module? I mean, which image they were showing?
I think he's been rolling through a bunch of the different animations and whatnot.
We're talking about the gateway now.
I believe we're at the gateway at this point. Yes.
What we planned on doing with the gateway, and this design, by the way, is outdated. Me and Tom have talked about more efficient designs, a torus design,
Okay.
Which would be lighter and have more volume.
Is that the right animation we're going to refer to?
Yeah, that's
Go ahead
actually
and
that's
take
the
that,
gateway
Dennis.
right there, the full
Yep.
gateway. And what we planned on doing is building the hub pretty much the way you see it designed. The LGA is probably going to have some changes to it. The habitation ring would be more torus shaped, and what you see between the hub and the habitation ring of the LGA is an area we call the LGA recreation area. And that may have a slightly different design also to have more volume, because that's kind of the play area for people to play inside. So the question is, what kind of hull material we use in multi-layer and so forth? We've talked about that quite a bit. It depends on the amount of protection that you want. If you're in low Earth orbit, the amount of protection doesn't have to be that high. If you're in higher orbits, you may want to have something that Tom would call high Z, low Z, high Z for
radiation.
For radiation protection, for higher levels of radiation protection. That's a lot of weight, though. Being in low Earth orbit would probably keep it a two-layer system, and it may not even be metal. It may be carbon fiber or something like that to make it fast and easy.
We have to worry about micrometeoroid impacts as well, yes?
We would probably use something like a Whipple shield on the exterior for something like that. You're protecting against multiple things. There's space radiation, which fortunately in low Earth orbit is nothing like what you get outside of Earth's magnetosphere, but you do need to pay attention to it. And there's also micrometeoroid, space debris, and so on. You don't want to have to move the entire station for every 10th millimeter piece of something that's going to come by. So you'll need something on the exterior to dissipate the energy of that incoming particle, which Whipple shields can do that. A Whipple shield is multiple layers of material with space in between, so that when a particle hits the first layer, it shatters and shatters part of that material, sending out a shower of particles, each with much less energy than what came in. You get to another layer and those lower energy particles hit it and then generate another secondary group of particles, again with much less energy than what came in. And eventually you dissipate the energy per particle to the point that it can't penetrate a layer. And so you have enough layers that you completely dissipate the energy of these small particles. For large things, like somebody loses a 6-inch bolt, yeah, you'll probably need to move the station or send out a pod that will intercept it.
I mean, it depends on relative velocity, right? That 6-inch bolt, tapping against the side is not a big deal. That 6-inch bolt hitting it at 20,000 kilometers an hour, a bigger deal.
Yeah, and because inclinations of orbits, just throw something into orbit, say off the ISS, it doesn't stay in that orbit forever. Things cause precession of the orbit, change of the eccentricity of the orbit. Sunlight can do that. Magnetic fields can do that. Various things can alter orbits of stuff that's up there. So just because you lost a bolt from your spaceport doesn't mean that 3 years later when it comes back, it's only going a couple of centimeters per second. If you've changed the inclination of that orbit and eccentricity of that orbit, it may come back at 4 or 5 kilometers per second rather than centimeters per second. And so that's something you really have to pay attention to, and that's why there are groups that monitor everything from a few millimeters up in orbit. They monitor tens of thousands of things in orbit and let places like the ISS know you've got something coming in, you need to make this orbit change to miss that.
And this gives monetary funding to a whole new industry again. Who's going to monitor this debris in orbit that could threaten the space station? Who's going to go out there and clean it up for us? Now we have a better reason than ever to go out there and do this, because we're going to have people in danger if it's still there.
Sure.
So once again, this is more money in the direction we need to go.
I mean, you're looking to put one of everything in there, right? There was the dining hall that was one of those images. I think has already been up.
Yeah.
You're going to need chefs for that. You're going to need people to serve tables. You're going to need people to all of the things for that. You're going to need engineers to design this. You're going to need construction workers to help build this. It sounds like a lot of this will be automated, but you're still going to need humans to do a lot of this stuff. So we're changing from a mentality of just sending humans to space to do some research to humans living and working in space. Truly, their job is in space.
Exactly.
That's what they actually do.
Primarily the spaceport is basically an airport. You're going to have approach control. You're going to have people doing operations in the bay and so forth. And then surrounding that, you basically have hotels. That's the best way to think of it. And there's all the regular hotel people working in there, people working in the restaurant, people cleaning the rooms. Just as you mentioned, lots of different jobs that we see down here, you're going to have up there once again. It's a recreation of our society down here up there.
Zwiebe, not sure, asks, I tried to find it on the website, but I couldn't. What's the estimated price for the total gateway?
We've never gone that far.
1.21 gigawatts.
We've never tried. This is what me and Tom have really kind of done. We've estimated what it would take to try to build the hub and the LGA, and that we haven't gone to the MGA, because we think the MGA is going to be built using in situ resources. It's going to be mined, it's going to be all done in space at that, but we're not going to be lifting anymore. So that's an equation you can't really work on. When we think about the price of the gateway, it really comes down to the price of launching materials in space, because the hub and the LGA are all going to have to be lifted from Earth. And after that, we don't got to worry about it so much. From the moon, maybe, local materials and so forth. But those two are the ones that we really have to worry about how much it's going to cost. And it just comes down to launch costs. The actual materials themselves, they're construction materials. They're not that expensive. That's why we like to tell people at SpaceX, if you lose a load of construction materials, big deal. Your insurance cost for this is going to be a lot lower. We don't care. We're going to make more construction materials. That's easy. It's the launch cost that gives you the idea of what it's going to cost in the end. And that's really high. We're talking, for the hub and the LGA, we're talking upwards of $300 billion in launch costs.
Is that today's prices, though? Because we look at what Blue Origin and SpaceX are both doing. They're both trying to launch their rockets over and over and over again, more like an airplane. You start doing that, your costs go down, because you've already built the rocket. You don't have that high upfront cost anymore.
Good point. We used $500 a pound as the basis, because right now it's somewhere around 1,000 and so forth. We know it's going to come down. With larger launch contracts, it's going to come down more and more. Now it's going to be below $500 a pound at some point. We don't know when, we don't know how, but that's kind of the basis that we used of launching. And this was, once again, our numbers are old too. We used Falcon Heavy. This is the numbers that we generated, the weight of the gateway and the number of launches it would take to launch that kind of weight. That was 3 or 4 years ago. We're going to have to update this. And our designs changed too. We have a more efficient design that's lighter. There's newer materials out now. So we're behind on this. And we're probably not going to update that because we're focusing on von Braun. We know von Braun has to be built first. We know we're going to learn a lot about how to build a spaceport from von Braun. So, the numbers that we had, although they're accurate at the time, they're outdated.
And the results of von Braun will inform how we design the gateway. So trying to design the gateway now before having done von Braun would be premature. There will be a lot of things that we would have to change after we've flown von Braun.
So we've bounced around a lot. I think I'd like to end on this. You've got a lot of really great stuff going on. You've got a lot of different projects you're working on. Can you give us kind of, to close us out, kind of a timeline of first we're going to do von Braun, then we're going to do the lottery, then we're going to do gateway. How do all these pieces stack together in kind of a sequential mode?
Yes, that's definitely a question for me. The way that we have it worked out right now is the first thing we have to do is we have to have a construction industry. We have to have that, or we can't do anything. In order to have a construction industry, you have to have a construction project. And as I said before, a space telescope would be great. It's kind of small. A fuel depot would be better. It's bigger, but it's kind of limited. There's no pressurized volumes except for the fuel. Von Braun is what we've been looking for. This is the project that we want, and we think it could actually happen pretty quick. There's a lot of module makers around the world now. The modules for ISS were made in America for Boeing. They're made in Italy from Thales Alenia. They were made in Japan. All these people would love to make another module. Why not make a bigger module for von Braun? They could do this quickly. Our job would be to build a frame for von Braun, the inner ring, the outer ring, the water transportation systems, the power generation, all the things that's going to make the space station work to feed those modules and so forth. And our designs for von Braun are improving every week. You'll see new stuff in 10 days. That is a progression up to that far. Now, In the meantime, while we're building Von Braun, we're also going to be encouraging people to join the Gateway Foundation, because it's going to take a number of people to change the laws in one particular state. And it only takes one state to start this whole thing. But it's going to take a number of people to do that. Once we have reached that critical mass of people, now we can vote in to have the lottery running. And it's going to be an argument. People are going to argue, why do we need to have a private lottery to go out and fund the construction of a spaceport? But we know why. We're space people. We get that. We know what it's going to do when we have thousands of people going to space every year instead of just a couple. So once you have that going, once you have that lottery started, then you can start on the Gateway. Now we can start on Gateway things before that, the tools that are going to build it, the bots, pod, the drones. We're going to need that for Von Braun. That's going to be privately funded. We even have a new branch of the Gateway Foundation, which is going to be orbital equity to help with that kind of thing. That can start right now. That's going to be, we're going to be talking to people, module makers around the world within a matter of months of who wants to get involved in this. The newer images of Von Braun, not the ones that we have right now, but some that I've been just working on today, they're going to show dream chasers or some other kind of escape module on each one of the habitation modules. Because these people are going to need a way off this thing if you have a Titanic situation, if something goes wrong and everybody has to go down. We're talking maybe 24 of these separate escape vehicles, a Dragon, a Constellation.
It would be kind of cool to see a space station with 24 Dream Chasers attached to it.
And we'll give you an image of that within days.
That would be really cool.
Yeah.
That would just be really cool.
So you're starting to see what kind of an economy is going to be created around just Von Braun. The module makers getting involved in this. The people who are going to make escape vehicles getting involved in this. The people who are going to be making the construction equipment. That's how you get momentum of an idea whose time has come. So we're going to build Von Braun, which is going to create a construction industry. We're going to start this lottery somewhere in there, and that's going to give us the gateway.
Now, you mentioned people joining the Gateway Foundation, and they can do that today,
right?
Yes. So, I mean, you need people to join the foundation, and then you also need people to get the word out as well,
advocate.
Right? Advocate for building, living and working in space is really what you're advocating here. Is moving humanity into space.
Yes.
So, how can they do that? Like, what do you need from people if they're like, my God, this sounds awesome. I want to do something here. What can they do right now?
They can join the Gateway Foundation, and they can help us. Tom's a scientist, and I'm an ad hoc businessman trying to make this go. We need people who are going to change our website into more of a user-friendly system, more interactive. We threw this thing together, and we don't want to spend our time doing this. We want to build a space construction industry. We need help right now. People who can create imagery of the things that we're talking about, because our ideas change. We need our images to change too. We need help. We need members to join. We need people who are going to say, yeah, I want to help. I'm going to build your website for it. I'm going to build social media around this idea here. That's the kind of thing that we need. We need to reach this critical mass of people who want this to happen.
So right now what you need is people's time and talents, right?
Yes.
So you're looking for people who maybe have a good design aesthetic to maybe help out with the website, maybe help clean up some animations. You're looking for social media managers who are maybe good at corralling the masses and being like, hey, here's what's going on, out there. Maybe you need some programmers to help program some cool features behind, the website and get people excited. So you're not necessarily asking for money right now. You're saying, although I don't think you're saying no to money either, I would assume.
No, we don't say no to money.
Yeah, well, no. that would be crazy. So for some people, maybe that's the thing they have. Maybe they don't have time, maybe they have money.
And we take donations.
Sure, of course. So, if you've got time and a talent and you're just good at something and passionate about something and you want to help, just reach out through the Gateway Foundation and see if that's something that you need right now. And
we need it.
And help, that's how people who are watching can maybe help shape the future.
And when you speak of money, people, in November, I went up to Seattle, where The Economist magazine was getting together about, the business end of space. And I went up there to meet one guy, Steve Jurvetson. He was one of the people of Draper Fisher Jurvetson. And I met him, and we had lunch together, and we talked about this idea, and he was interested. He's not doing much right now. He's got his own thing to deal with. But that's the kind of thing that we also need. People who are good at this, at the business end of handling large amounts of money. So we need help on every front.
Yeah, I think everyone has like a passion or something that they're really, really, really good at, that they just love doing. And it sounds like you're looking every one of those things.
Yeah, eventually,
So
definitely.
if this is something that interests people, interests our viewers, or interests even people out online, it sounds like just contacting you through the Gateway Foundation and seeing what they can do would be of great help at this particular juncture.
It really
and
would.
How cool is it? Especially, I know a lot of people watch the show and they're not necessarily in the space industry, but they maybe want to be in the space industry. What a great way to get started.
Yeah,
right?
and because we're talking about a spaceport, we even need chefs down the line, like you're saying. We're going to need people to cook up. It's every walk of life that we're going to be creating.
I would argue you may even need them right now. Like if you're talking about building a spaceport, having someone go, okay, I can design the food for space. I can work on this stuff. And then actually being able to say, this is how we're going to feed you in space. That you can actually say, we've thought about the food in space. That problem is solved. We've thought about how to transport these things. That problem is solved. So even if you don't need people to actually cook the food right now, one could argue you still need one of all of these people to actually give you the data behind what you're actually looking for.
Exactly.
I think what you're working on is extremely exciting. I was really excited to bring you on the show, and I'm glad you could be here in person because I just think it's really cool. And it's really, really hard what you're trying to work on.
We're glad to be here, Ben. This is a really cool show that you have, and thank you for the opportunity for telling people about it too.
Yes, thank you.
I wish you the best of luck. Hopefully you guys will have a bunch of updates out in the next few months, and certainly stay in touch. We'd love to see what you guys are working on and kind of get some progress down the road because your vision's a long-term one.
It is.
It's not a decade or 2 decades or 3 decades. It's a very long-term vision.
I wouldn't say it's that long.
I think I think that you've got short-term stuff, medium-term stuff, and very, very long-term stuff. So I think the whole vision as a whole ends up very long-term. And when you look at it, I think you end up with a good chunk of humanity living and working in space.
That's our goal.
I think that's.
And that, having humanity being a spacefaring species, is not short-term, mid-term, long-term. It's forever.
Yes.
See, there you go. You have a forever timeline. That's all right, awesome. Thank you guys so much for taking time out of your Saturday. I really appreciate it.
Thank you, Ben, for having us.
Thank you.
All right, we're going to take a quick break, and when we come back, comments from last week's show. So stay tuned. We'll be right back.
Science. It both draws us together and tears us apart. Brings discoveries to cure us and threaten us. It is neither good nor evil. It is what we decide to make of it. There is so much more to learn, and we are curious. Together, let's explore the science of tomorrow.
Before we get into comments from last week's show, I did want to thank all of the patrons of tomorrow, and by that I meant citizens of tomorrow, who helped to make this specific segment of this episode happen. These are the Escape Velocity citizens. They have contributed $10 or more to this specific episode. We also have our Orbital citizens, who've contributed $5 or more to this episode. They get a bunch of really awesome things. And our Suborbital citizens, who've contributed $2.50 or more to this episode. To find out how you can help crowdfund the shows of tomorrow, head on over to patreon.com/TMRO. All right, last week we actually had Carrie Ann on. She was our commander, and they had the incredible Jeff with Death Wish Coffee. It's the strongest coffee in the world to the strongest coffee off-world. Actually, my script just stops, says, in the world to the strongest coffee. But off-world, yeah. It was a really fascinating interview. So we got some comments on that, and then we went into a bunch of other different topics throughout that particular show. It was all over the board. It was really cool. So let's get started with Wollable from YouTube, who says, I think we should collect all the space junk into a single orbital ring of junk, and in the future we could recycle this material once 3D printing and on-orbit construction reach their potential. That was an apt comment for this particular show.
Yeah, what do you know?
Right? Use the resources that are already up there. It feels like we are wasting all the energy we used to get out of our gravity well. Potentially, the thing to remember is that there's still going to be decay there, right? So, like, you stick it into a big blob, but, unless we get something up there, if it's in low Earth orbit.
Yeah, we could build shepherd moons with it
Yeah.
Build shepherd moons out of the debris to keep the rest of the debris in place.
Are they going to be like Saturn shepherd moons, where they have
Yes.
like a little skirt of
Little,
material around a big hunk of
ravioli.
material? Yeah, little ravioli-shaped shepherd moons in orbit, made out of debris. So
Either
just
that or petticoats and a
regu-
crook.
Yeah, just like a whole bunch of satellites and stuff, and then on the outskirts there's like leftover coffee cups and all the other stuff.
You know, I feel like
there,
that's
so.
in some sci-fi show somewhere at some
Yeah,
point.
there's gotta be, so.
But you know, I think it depends on timing, though, right? So if we
Yeah.
can get up there quickly and pull and use those resources, and if they're the right orbit for us to get to,
Right.
Because if they're way over here and we need them way over here, that's going to take a ton of energy to move around.
Yeah.
So I mean, maybe, but you know, there's also energy that goes into moving them.
Yes.
So there's a lot of all right, next up is from, is that Thom Westcott, which is from YouTube, just says, just saying, Canada has been fiercely, proudly metric for 40 years, and carpenters still use 2x4s. Imperial.
Yes.
Besides, if we're talking about chauvinism, the second and meter are based on the rotation and diameter of the Earth. Isn't it time for a truly universal standard? I mean, metric is basically standard. So the point of this was in comment. This is a comment. This is Inception, right? So comments last week, we talked about how, hey, why are you using imperial? And now we're bringing it up again. And the stance is officially this show uses metric, but we're all American here, and America standard is imperial for reasons I do not understand.
There was a
and
very-
so we are going to screw up from time to time, and we are sorry for screwing up from time to time. Google is your friend. Use the conversions. That's basically how we came to. And then that spiraled into.
Get an app.
Spiraled into so many. Get an app. Yeah. Hey Siri. I did that earlier today. I was trying to figure out because we have someone from the Upside Down visiting.
Oh yeah.
Right. So I was like, hey, what is it from Celsius to Fahrenheit?
Oh, geez.
Yeah.
Oh, in these modern times, if only there were devices to help me out to do this.
I know.
I just don't
Where
know
can I
what we're gonna
find
do
one?
with
Yeah.
this.
Yeah,
I
look
just
at
I
the
can't.
abacus.
If only. If only.
All right, so yeah, is it time for a truly universal standard? I feel like metric truly is a universal standard.
Yeah.
Although getting into timekeeping is based on the rotation of the Earth, and that's going to be a whole new thing when we have space stations like Gateway
And
Up,
then
and
which time are you
you've
gonna
got
go on?
spacecraft event time, you've got Martian time, you've got all this different time. Don't worry, we're going to get to time in a later comment as well.
And
There's time for it later?
I mean, there's also
Oh, hey!
in astronomy we have universal time. We also have sidereal time as well. So.
Why are you messing with time?
So it's not us. It's actually everyone else being wrong about time.
Speaking of time, Paul Warlow from Facebook says, Greenwich Mean Time is coordinated universal time. We set the world time at Greenwich. So I actually did a reply to this post on Facebook and actually kind of explained how all of that does indeed work. The universal time, so think of Greenwich Mean Time not as a time standard anymore. That's no longer correct. Now think of it as a time zone only. Think of coordinated universal time as a time standard, but not a time zone. So GMT is still there kind of as the line of demarcation of like where time zone 0 exists. But Greenwich Mean Time also used to be used as a time standard, but is no longer done that way. Coordinating universal time is a time standard, and it is actually based out of France, which is why coordinated universal time you'd expect it to be CUT is actually UTC because it's French.
Universal time of coordination.
Sure, it's French. And actually what's funny is even the French acronym doesn't work with that, but they decided that if it doesn't work in France and it doesn't work in English or French and it doesn't work in English, we'll make it work for no one then. So we ended up with UTC for coordinated universal time.
Universal coordinate de time? I don't know.
Sure.
I don't know French, so I'm very
Sure.
sorry if I just insulted.
So,
I'm sorry.
coordinated
That was not-
universal time is actually loosely based on atomic time, and atomic time is done by taking atomic clocks all around the world and averaging out that number to actually get you the exact moment in time at any precise second. So actually, the time is not set at Greenwich Observatory anymore. That actually used to be where it was. It is actually now set in France. Additionally, Greenwich Mean Time, that line which used to go through the Greenwich Observatory, no longer goes there and is actually about 100 miles to 102, meters to 102 or 103 meters to the east. So everything has moved and changed there you go. There's my little time thing, and that's why UTC is the standard time for the show.
Okay.
And stuff and things.
That was a good talk about that.
Yeah, that wasn't really a conversation. That was me just telling you the way it is.
Thanks for coming to Ben's TED Talk.
Yep. You're welcome. Good night.
I feel like you could also go that long about daylight savings as well. Or
Savings.
Sorry, savings.
How dare you, Jared?
sorry,
On that note, I'd like to thank all of our ground support citizens for helping to make this specific segment of this episode happen. We've got science coming up next, and I'm on that show too, so you definitely want to watch that because I'm going to go crazy.
Is Space Force going to use imperial or metric? Because I feel like if they mix it up, they may miss by like 90 feet.
Obviously, Space Force is imperial because it's
Obviously.
the Space Force.
Gotcha.
To find out how you can help crowdfund the shows of tomorrow, head on over to patreon.com/TMRO. See what we did there? We gave you a little bit of extra time to find your name. A little bit of extra.
Make
You're
sure to
welcome.
grab your
That's what
Sharpie
that
and
was
circle
for.
it.
Guess what? We got a round table coming up next week, which is going to be a lot of this shenanigans happening. And you know what the topic's going to be? Because we don't. You're going to vote on it. If you are a citizen of tomorrow and you've got voting rights, head on over to patreon.com/TMRO. Sometime this next week, we will have a survey up for you to choose what we will talk about.
Yes, tell us what to get angry and say bad things about.
TED Talk about.
TED Talk about. Yeah, if our citizen from the Upside Down had her way, we'd talk about unicorns and glitter.
Well, I think unicorns are pretty
she's
good.
Bouncing over there in the corner.
As a millennial, glittered unicorns are great. So
There is no space after dark because tomorrow science is up next. Thank you everyone so much for watching. We'll see you next week.
Bye.